Alright, we are going to be working on the going golfing problem from the notes. In this problem, a golfer imparts a speed of 30.3 meters per second at an angle of 35 degrees to a golf ball. It lands on the green, which is at the same elevation as the initial shot. We want to know how much time the ball spends in the air and how far does it go before it lands. I've already drawn the picture, so up here you'll find our golfer hitting the ball at an angle. The velocity in the x direction here, velocity in the y direction there. We need to find those components. I've written down what I know in the x direction and what I know in the y direction. We know that the distance in the y direction is 0 because it starts at the ground, goes up, and lands on the ground. So the total y displacement is 0. The acceleration is always negative 9.8. And the distance in the x direction is our question mark, and we're going to find the times in order to find that distance. So the first thing we need to do is find the velocity in the x and y directions. So our velocity in the x direction, that's the adjacent side on this particular triangle, and the angle right here would be 35 degrees. So we're going to use cosine of 35 degrees. And we're going to multiply that by the velocity of the projectile, which is 30.3 meters per second. When we multiply that out, make sure you're in degree mode, and we will get 24.8 meters per second. And that's how fast the ball is going in the x direction. In the y direction, velocity in the y, that's the opposite side, so we use sine. It's the same angle, 35 degrees, multiplied by the initial speed, which is 30.3. And we get that the velocity in the y direction is 17.4 meters per second. Now I can plug those in to my x and y stuff. And now I have enough information in the y direction to solve for time. I need 3 things. I've got it. So now I'm going to pick the kinematics equation to solve for time. The kinematics equation I'm going to choose is the d equals v naught t plus 1/2 at squared. Rearranging for time, this is a quadratic, so you have to use the quadratic formula. And we would get time equals negative initial speed plus or minus the square root of initial speed squared plus 2AD, all divided by the acceleration. And what we would do is we would plug in, everywhere there's an initial velocity, we plug in 17.4 meters per second. Where there's an acceleration, negative 9.8, and a distance, we plug in 0. When we do that, we'll get 2 possible answers. The time will be either 3.55 seconds, or we would get 0 seconds. Because it's a quadratic, we have 2 possible answers, and the one that makes sense is obviously the 3.55 seconds. Now we're going to use that in the x direction. Our equation in the x direction for distance is velocity multiplied by time. So we're taking our x velocity of 24.8 meters per second, multiplying it by our time of flight of 3.55 seconds. And when we multiply those two together, we get 88 meters for how far our golf ball is going to go. And that's how we solve the going golfing problem.